All right, we'll go ahead and get started. My name is Jesse Phelps. I am from St. Louis, Missouri in the US. This is reverse engineering the Bluetooth light bulb. So how did this come about? Well, basically, I was interested in having build lights. And when I contacted the company about doing this, they said that they wouldn't really help me with it at all. So to me, it was challenge accepted. And I wanted to just reverse engineer it and figure out how does this actually work and how can I use it for my own purposes. And the reason why I wanted to have build lights, I'm an agile engineering coach at a company called Express Scripts. And we wanted to do something that would be accelerate our feedback loops. I mean, we had our build processes running, but it's just kind of fun and a team building thing as well to have a light that gives you that indicator of build status and success or fail. So that's sort of why we wanted to do this. And build lights are not a new idea. Lots of different examples of them are out there if you go looking for them. And I just wanted to buy the bulb that was Bluetooth and use that as my base for building on. So here's kind of the overview of what I'm going to go through with this. This is going to use Bluetooth Low Energy, and I'll talk a little bit about how this works. We're going to run TeamCity in a Docker container on my laptop to have our build agent, build server there. I'm using an Intel Edison for actually communicating with the bulb. And then we have a Bluetooth bulb, of course. Then we're going to do packet sniffing. We're going to do it a couple different ways. So I'll just skip that for now. Basically logging that data of how it's interacting with the bulb. Then we'll use Wireshark to inspect that protocol and actually figure out how the communication is working with the bulb to give it the instructions about turning on and off and changing colors. And then we'll put it all together and have our build lights that run when TeamCity is actually executing a build. All right, so Bluetooth Low Energy. So originally it was actually called Bluetooth Smart, and now it's BLE, basically, is what you see on everything. And it uses, one of the mechanisms that it uses is called GAT, and it's generic attribute. So that's kind of the key term to go Googling for to look up the documentation on if you want to dig into it more. And basically, it's a key value pair. That's essentially what it is. You have handles that are different addresses that are going to be on the device, and then you provide it whatever the value is that you're trying to set on that handle to get the behavior on that device that you want, or to read from handles to get the information that you want. So on a fitness tracker type of device, right? You may do a write to it and then do a read back from some other handle to get that data. TeamCity, it's just a build system. I guess kind of want to get a survey and see how many people use TeamCity and how many people use Jenkins. And anybody use something else? Okay, I'm just going to ask like a couple of you to see. What do you use? Either one of you two. Okay. Okay, all right. So I was just curious to see what people are using. So this same thing will work with Jenkins, and I'll talk about that. I mean, it probably will work with any of the others as well. I just haven't investigated it, so I'll talk a little bit about setting it up with Jenkins as well. So the key plugin that we're using here on this is the webhooks plugin. And this is the address where you can get that. And I think they actually listed in their official list of plugins now as well. And we'll get into setting that up. It's pretty straightforward as well. Then when I first gave this talk, Docker was still kind of not widely used yet, or any other containers for that matter. So again, I'm curious, using containers? Wow, I'm actually surprised. How about, I don't know what containers are? All right, good. So that doesn't happen anymore. All right. So basically, high level, it's kind of a lightweight VM, as everybody is already knowing. This is what I sort of gave for that overview, but we'll just skip past it since everybody at least is aware of it. So this webhooks plugin, there are three main things we're going to get back from this. TeamCity is, when we configure it, it's just going to dump this payload over to the address whenever build state changes on TeamCity, and we're just going to extract from that plugin these three values, or from this JSON payload. Those three values are what we're going to use to actually control the bulb. So just showing you what's coming from that. The Intel Edison. So this is actually the Edison. It's just this small little chip on here. And then the rest of this is an Arduino breakout board for the Edison. The Edison is pretty nice at its time, anyway. It was pretty well spec'd, and in particular, a lot of embedded devices, a lot of the microcontrollers don't support the different protocols on chip. You sometimes have to bit bang those and go download other people's packages and libraries. This was all hardware baked in, and as I said, this was the Arduino breakout board. Well, this industry is pretty competitive, and Intel has discontinued all of their embedded devices for the hobby Arduino kind of space because everybody was just coming in at such a low price point and basically not making any money that there's no room for them. However, the Raspberry Pi 3 does support all of these things now baked in. It's nice and cheap. So everything I'm going to show you here today, I have done on the Edison, but should work on a Pi 3. I haven't actually set it up myself yet on here, so there may be a few idiosyncrasies, but if you go get the code and test it and make it work, send me a pull request and I'll bring it in as another branch. So anyway, just letting you know that I'm doing it on the Edison. It all should work on the Pi as well. And then I threw the specs out here on the Pi, because you can see this actually trumps out the Edison now as well. I used the Edison at the time because it was the only thing that had Bluetooth and Wi-Fi both baked in. And now the Pi 3 has all that stuff too. So, all right, so then the Lightbulb is just a Bluetooth bulb. I got this one from BluetoothLightbulb.com. They were selling them through Amazon. I don't know what to recommend to buy in other countries. So this was just what I had from the US. But the same principle should apply to all of them. I suspect that at the end of the day, there's probably 2 or 3 chip manufacturers in Shenzhen that make all of them anyway, and they're just branded and sold different parts of the world. So it should probably even be the exact same protocol, at least worth trying. And then we'll do the packet capturing. So I use an iPhone, but I got my mom's old Android device just so that I could do this, because she was just going to throw it away. So on an Android device, you can actually go into the developer options if you don't know this already, and you can set this enable Bluetooth HDI packet capture, or Snoop, it's called on this one. Now, in terms of where that data will go, so what this will actually do is have your Android phone log all of its Bluetooth packets. And in terms of where that data gets stored, that actually seems to depend on the specific manufacturer. So for mine, it actually puts it on the SD card. So whatever brand you have, if you're trying to do this, you'll have to just go research and figure out where that data is going to get stored. And then Wireshark. Who has used Wireshark? Awesome. Almost everybody. So we'll just jump over that. And then putting it all together. So we're going to run a node server on the Edison. Again, should work fine on a Raspberry Pi. And then use the TeamCity webhooks to notify the Edison. And then the Edison uses an NPM package called Noble. And that's actually where I suspect that there'll be some potential idiosyncrasies with getting it to work on the Raspberry Pi, because some of the, I'm just guessing that some of the handles and information that's set up and working on the Edison is going to be different on the Pi, and we'll have to work through. But that's the package that I'm using to do this. And then Noble actually sends those handle communications off to the bulb. All right, so let's dig in. So the first thing to do here in terms of reverse engineering something like this is I need to have some data to analyze and see what's going on. So I'm going to hand wave over and say I've set this phone up to packet capture already, and just turn on the bulb. And I'm really going to be tempting and testing the demo gods today, because not only do I have all the hardware, but I've traveled with it across the world. Who knows if my power converter is going to work and hold out. It didn't work. I think we blew the hair dryer or something when we plugged into it, so we'll see what happens. All right, so I'm just running the app on here. It's called Magic Light, but there are dozens of them, and lots of them are paired with the manufacturer of the bulb, so just pay attention for that. So just going to kind of run through colors in here, and what I'm trying to generate is I want to see some data that I might be able to ascertain a pattern in that I can correlate with something about color information or some sort of on-off, right? So let's just hit the on-off button a bunch of times here. So in my mind anyway, this should give me something that seems to be the same values just toggling, right? If I'm just turning it on and off. And this should give me, I'm hoping, something that is color data. And maybe if I do this, and I don't know if you can see well or not on that bulb there, but I'm kind of just flipping back and forth roughly in the same colors. And then there's also some sort of built-in functions, that's what it calls them. So I could set it on one here that's a blue gradual change. And I'm not actually doing it now. I've just set it, and then it's doing it itself. And maybe I'll pick a red gradual change as well. And then there's a speed slider on here, and maybe I'll adjust that a little and see what we get. All right, so I've made some data. Now, I'm going to hand wave over getting that file off of here. It's just a file on that SD card and moving it to my laptop. And what also is implied in that is the actual data that I have in the file that I'm going to analyze is probably not going to be the same sequence and things that I just did, right? But this is the same exact kind of thing that I did when I did this before. It's just kind of a pain to get the file off of here, and you guys don't want to watch me do that. So let's go to Wireshark. And I've got this file in here, bulb.log, that I've brought in. Unfortunately, this is kind of the best I can do, I think anyway. Let me see if I can do. Oh, hey, look at there. We can make it bigger. Is that viewable for everybody? All right. So I know nothing about any of this at this point. I'm just know that I have the data, and I'm just going to go digging and see what's in here. Anything meaningful stand out. So let's expand some of this and see if I can find anything that resonates with me based on what little I know at this point. So I'm just kind of scanning through the data, and I see this GAT in here, right? Well, I know from just having read that that's how this is actually working. It's using this generic attribute protocol. So what if I just look at this, and I don't really see anything here that seems meaningful or helpful to me yet. Let's kind of keep digging and see if we can keep looking at these GAT items. So let's kind of jump down a little here, see if we see anything else. All right, so I see this ATT in here. That might be interesting. And the timing on these seems very, very close together. So maybe that's me spinning through a color wheel or something. There's a whole bunch of data going, right? And I see these right handles and values. And, as I'm looking at that, the data kind of seems like there are only 6 bits in there, or not 6 bits, but 6 hex characters in there that are changing. I don't know. Maybe those are RGB values that might be in there. So at this point, I kind of feel like I'm maybe getting somewhere, but now I have to figure out how do I actually get this over to the bulb just so I can test it and see what's really happening. So the Intel Edison, let me hook that up now. Always have to rotate the USB plug 3 times before you can get it to plug in. All right, I got to give this a second to boot, and then I also need to drop this connection on the bulb so that the Edison can pick it up. And then, all right. So first thing we'll do here, I'm sure that this is probably a little harder to read. Can you guys in the back read that okay? The serial terminal down here? All right. All right, so I just have a serial terminal running on the FTDI USB connection to the Edison here. And I got to find where this is real quick. I always have to find it again. So there's a library that you get called GAT tool. Okay, it's in there. All right. So this, so BlueZ is the Linux Bluetooth framework, and there's a library in there called GAT tool, and it will actually allow you to send these packets just from the command line, just manually. So that's what you'll want to use if you're going to try to mess with this at all. So a trib, and then, all right, so GAT tool. And then, oh, one other thing that's always kind of fun to show is the, well, on the Edison, I got to do this real quick too. On the Edison, by default, when it boots up, Bluetooth is turned off. I don't know about on the Pi. Does anybody, has anybody done any Bluetooth work on the Raspberry Pi? Okay, so I don't know on the Raspberry Pi. There may be some equivalent to this. On the Edison, you have to actually run this application called RFKill and tell it to unblock Bluetooth. So now the Bluetooth the packages will be actually accessible on the Edison. There may be some idiosyncrasy like that on the Pi as well. I don't know. Okay, so GAT tool. I need to run the. I forgot to do this before I came in here to grab the identifier for this bulb. So give me 1 second here. What is the thing? All right, to the Google. Let's see, this is BlueZ, Bluetooth CTL, that's it, okay. Bluetooth CTL. And then I'm going to tell this to scan. Okay, so this is just going to listen to all of the advertising devices. And doing this in a conference setting is always really interesting because the data scrolls so fast that it actually will often flood the Edison and I have to reboot it. So it's kind of fun. We'll just see what happens. All right, so I turned it off pretty quick, so we're okay. But this is all of the devices that are advertising a connection capability of some kind. And most of them you'll see are just MAC addresses that don't tell you anything about what they are. But this light bulb is LED blue. And somebody has a Vivo Smart 3 that's advertising as well. An Ionic, a Charge 2. I don't know what these things are, but anyway, you can start to see interesting things show up. And if there's any information available online that tells you what those devices are and what their protocols might be, obviously there's some vulnerabilities there that you might be able to learn interesting things with. Okay, so this LED blue is our bulb, and this is its identifier. So now we can use the GAT tool, and we can connect to that. And I gotta see what the. So we want to go interactive, and the device ID is that. Okay, so we are now connected to the bulb. So GAT tool, you have to tell it the parameters of what you want it. I want to be in interactive mode. This is the identifier that I want to connect to, and then you actually have to execute the connect command separately. So now I should be able to do a, let's see, I think it's right handle. All right, again, to the Google. Okay, there you go. Char right rec. That's what we want. So that is how you actually execute the right handle. Char right rec. And then let's go back over to Wireshark here. And let's just take this one here kind of at random, right? We see a whole bunch of packets that are all being written to this 0043 handle. And as we looked at it, we kind of see that maybe those are hex values in there. So let's just pick one of these at random and go write that and see what happens. So 4.3. And then I'm going to go copy the value from here. And you actually have to remove the colons for get tool. OK. And it disconnected me. All right, so it worked. I don't know if you saw when I hit that enter, the light changed. So let's mess with it now and see if we can actually ascertain what in here really is those values that are the hex characters for the color. So it looks like perhaps those first 4 characters are static, and it's the other ones that are changing to, oh, nope, those first 2 changed as well here. So let's go with we'll leave the first 2 characters the same and then mess with the next 6 and see what we get with those. So FF, I don't know, that feels like it might be an R that's totally on. What if we say zeros for these other ones? Look at that, it's red. And then maybe a green, and perhaps a blue. How awesome is that? You all really want to be up here to press the enter key and make that happen, don't you? I know. There was jumping up and down and you know, woohoo, when it actually worked the first time. So, all right, so now we know how to, at least from the command line here, change the color. Let's go look and see what else do we see in the packets over here that might be interesting and something we can look at and use. So let's just kind of jump around a little through here. See if we see anything that looks significantly different. So far, just sort of randomly picking them, they all basically have the same structure. We'll get to some different ones, I promise. They're in here. That looks different. Let's see what that does. It's the same handle, so we know how to do that part at least. I feel like nothing really happened. All right, this one has a 9 instead of an A. Let's try that and see what that does. So it's just the A and the 9 are flipping. Oh, there's a 7. Let's see what that does. It seems to just be the same. So rather than continuing to dig and find other examples, I'll just, in the actual log, I'll just pull them out of the code that I've already written. So that's slowly changing blue. So maybe these are all the those color functions with a changing value in them. And I guess those other ones were just really slow changes. So what if we up this? What happens? Actually seems to be changing slower now. So there's a little faster with that one. So I think that's our functions. And then you could obviously just go through and actually identify what all those specific function codes are and the change rate. I only need this one for my purposes of having a build light. So leave that one in there. And then there's one other one that I use in here for discovering a bulb. Identifying. There we go. So I use this one as well which is rotating through the colors. So that way I can, because those identifiers, it just says LED blue and then a numerical string. Well, I don't know which bulb that associates with. And we actually had multiple of these. So I use this function to actually cycle through and show me what's really happening. So, all right, any questions about this part of it at this point? Pretty straightforward? You all feel like you could do that? All right. So now let's jump over to TeamCity, and I got to run this on the Edison. All right, so I actually, for the purposes of doing this demo, I'm using my phone as a hotspot, and then I have the Edison and my laptop both connected to it, so I don't have to deal with any other potential network issues. So just throwing that in there. OK, so my boot up here makes a call off to TeamCity and asks it through the APIs, hey, give me a list of the build configurations that you have in TeamCity. Jenkins has the same thing. You can just ask for that list, and then I'm going to display that. And then you'll see what this actually starts doing immediately is listening for, it's doing discovery and through Noble, and listening for anything that is advertising with that LED blue prefix. And if it sees it, it immediately just tries to connect to it and grab a handle to it. So now I have this bulb, and you saw that immediately went green. That was that indicator of it's connected. We just have it by default. Assume that the build that it's associated with last state was good. That's what we're doing. So it's the next build that we'll see what happens. And then this just is outputting for diagnostic purposes what the configurations we got from TeamCity were. So then now if I jump over to the web interface for this, it's nice and simple. Here, I'll increase the size. So I just have lights that have been identified, and then the build configs that are in TeamCity. And as I mentioned, I don't know what that is. And when I've got 5 or 6 of these, I can't associate. There's nothing on the bulb that tells me that. So if I check it and hit identify, then that bulb will rotate through the colors for just a few seconds. So now I know which one it is. And then I'll associate it with this build lights build. And then now over here, so the way that I've set up this build, it really doesn't do anything except sit and wait for, dang it, hang on, I gotta go to the config. Edit settings, there we go. All right, so this is just running a command line. It's doing a sleep 10, and then I have an echo fail, or I'll comment that out, so we know success or fail, and then that's what I have as the failure condition. So the webhooks that I mentioned, let's talk about that real quick. So this plugin will allow you to set them up at various levels of granularity. I'm just using the one that's at the highest level here for all builds. Just send the JSON formatted build status information to this address. So the Edison is the node server is just listening there, and when that payload comes in, I just inspect it and pull out those values and associate it with those build configs that we identified initially from making the call via the API. And then I have that assignment that I made to the bulb. So that's all that's happening there. It's just a lookup table linking that build to that bulb, and then we pull out the status and toggle the light accordingly. So easy enough? All right, so let's fire this off. Do we want to have it fail or succeed on the first go-around? Fail? All right. So I'll go edit our command line here and uncomment the echo. All right, here we go. All right, someone has started a build. Who broke the build? And then we can go in here and do this again. And what I've learned, and the reason why I chose the 10 seconds is sometimes the agent is faster than the server in terms of actually doing this. So when I had that, if the time was too small, if I had it like a 1 or 2 second time frame, which no build runs that fast, so it's okay, it actually would do weird things where, like this right here, you see the bulb changed to green, the server didn't update yet, right? So there's a little bit of a lag between them, and the agent is actually what's firing off those webhook calls, it seems. So anyway, just had some idiosyncrasies. That's why I have it sit for 10 seconds. So, all right, build is green. Everybody's happy. It's all working. So let's unpack a little bit of that code in there. So it is also worth disclaiming that this is not how I write production code. This is how I hack when I'm just trying to play with a project. So it's all one giant file, and I was learning the entire time, and I just haven't bothered refactoring it yet because the MVP works, and why not put the proof of concept in production? Okay, so this is that payload we saw for the rotate the color, or not the rotate the color, but the slightly pulsing blue. And then we're just seeing that the build started is that notify type that we got from TeamCity. And then if we have a build finish and result success, this is solid green, finished fail, solid red. If we haven't interrupted, this one goes yellow, I think, or purple. I get confused about the additive or subtractive color when I'm actually writing this code. Which will that be? Should it be purple? All right, anyway, doesn't matter. So the build interrupted I almost never have happen. It's pretty rare that someone actually goes in and kills the build on purpose. So I haven't seen that one in a while. I forgot what it is. As I said, I'm just looking for that LED blue when this discover happens. And I'm just pulling off the numeric identifier then of the bulb and just reuse that. Now, one of the things that I have learned, though, when we got multiple bulbs is depending on the version of the bulb, the handle that this writes to, we were writing to 43. But this bulb starts with a number 7 in its numeric identifier. If you have a bulb from this same manufacturer that starts with an 8, then you have to write to 2E. So there are going to be some strange things that continue to emerge when you don't actually get the protocol spec from any authoritative source, and you just kind of have to deal with them on the fly. But it's kind of part of the fun. So that's basically it. Make the call to TeamCity here at the beginning. I mean, this is just where I'm setting up those options to that REST API to get the build types and pull out that data. The rest of this is pretty much just boilerplate JavaScript using Noble. There's plenty of documentation on how to use that. It's Node Bluetooth Low Energy is how that works there. So any questions about any of that? You guys are really easy. Okay, let's jump back over to the presentation here. So as I mentioned, slideshow, play from current slide. So as I mentioned, you can do the same thing with Jenkins. There's a notify plugin, and it's just part of their standard plugin repository. You can get that plugin, and you'll set up this job notification, and it's basically structured exactly the same as that TeamCity webhooks plugin is. You're just going to give it the address of the Edison or Pi or whatever you're using. And then their payload is a little different. It seems as if you'll just need to use these values out of that, and that'll allow you to modify your code to do the exact same kind of process here. I don't know about Travis and any of the others. Does anybody who uses those know? Is there a notification plugin of some kind? I'm seeing a couple of nods, so should be feasible to do over there as well and have exactly the same kind of thing happen. All right, so let's go back for a moment to this part. when I was talking about we're going to sniff the packets off of the Android device. Like, that was my easiest way to get the data. I knew just from looking online that Androids could actually log out their packets. Of course, Apple is never going to let you do something like that. So I got a hold of this Android device and did that. But then I was curious, what if I wanted to do this in hard mode and not actually have an Android device? And, or maybe I didn't have an app that I could even use on an Android device, and I needed to inspect this data and pull it. Well, that's where the Ubertooth comes in. Anybody familiar with an Ubertooth? All right, nobody is familiar with an Ubertooth. So you'll notice that it's distinctly not Bluetooth. And that's because to be something that calls itself Bluetooth, you have to meet the Bluetooth spec and get approval from the governing body and convince them that you've met their spec. And the Ubertooth intentionally doesn't meet the spec, because a part of the Bluetooth spec is that you only accept packets that are destined for you. And the Ubertooth says, I'll just accept everything. So you can hook up an Ubertooth and just kind of watch all the packets that are out on the spectrum. So this is how you would side snoop this information to be able to do the exact same kind of thing. So let me disconnect the Edison now, because we don't really need it. All that part is identical. I don't know, I'm actually wondering if I've violated some sort of international treaty by bringing it across country lines even, now that I think about it. You can ship source code, you can't take hardware. All right, so let's jump over to Wireshark again. So this is there. You can order the parts and you can build your own. You can spend like 3 times the price and just buy one pre-built, which is what I did because it's easier. And I'm going to try to demo this. I have a log file that I've already saved off that we'll probably have to go to for the exact same reason of the environment's just so noisy with all of us technical people in the room. But I can at least give you an idea of how it works and what it looks like, and then we can switch over to that other log file to actually see its data. Because its data is similar, but has a little bit of different structure to what you're going to see in Wireshark. So what we need to do here is, actually I'll go to, so from the command line, you're going to make a pipe. And on a Mac, probably on Linux, I'm going to make a FIFO buffer. And you do MK FIFO. Anybody ever done this before for anything? I see like 2 hands. So basically, I've already done this earlier, but I'm just going to make one that I'm going to call temp Uber pipe. And all this is going to do is essentially give you a pipe that devices can write, or something can write to, and other things can subscribe to and listen on. That's really all that's happening here. And then in Wireshark, you can actually configure, you can do manage interfaces, and you can specify a named pipe in here. And I've set up the temp Uber pipe, and then I'm going to specify that as the source for this data that I want to get. So that's running and listening on there now. And then I seldom actually memorize anything, as you saw, because why bother when the internet's there? So I just go to the wiki page for the Ubertooth. I kind of jumped past that. So the wiki here has a lot of data on the Ubertooth. We're going to do capturing Bluetooth Low Energy in Wireshark, and I'm just grabbing this command off of here, right? So I'm just going to pipe this out to that pipe, and then Wireshark will bring in all that data and do its protocol decomposition on it. I have to change this to Uber pipe. So you saw, though, how fast all this data is flowing, right? Like, this is a ton of stuff. And I'll leave that running, and if we jump over to Wireshark, you'll see we're getting stuff in here now. And there's a ton of it. And I'll tell you about one other little idiosyncrasy that sometimes makes this hard to do, especially with lots of things in the room. All right, so we're doing the same kind of deal here. And there's so much data here, I'm not even going to bother with trying to find it in there. I'll just bring in the known good file that I have. So, but I will tell you the idiosyncrasies. So, Bluetooth low energy, the sequencing of how the conversation happens with devices is you have devices that are broadcasting, advertising their availability to connect. And there are 3 channels that happens on. It's 37, 38, and 39. And the Ubertooth only has 1 radio on it, so it can only listen to any one of those channels at a time. What it does then is it listens for advertise, then it listens for a connect from something else. In the Bluetooth protocol, when a connect happens, they actually choose a channel at that moment. And it won't be one of those 3 advertising channels. It'll be a different channel. So the Ubertooth listens to what's advertising. The moment that anything does a connect and it picks a channel, the -F in the command line there is follow. And it will follow that connection to whatever other channel it went to and continue to pull that connected conversation's data. So in a noisy environment, it's really difficult to isolate a specific device. I haven't gotten into enough of the figuring out all of the Ubertooth stuff. Like, I'm certain I could probably go into the code somewhere, probably in parameters, and specify it's these specific identifiers that you need to follow. But I just haven't gotten deep enough into it yet because in my house, I only have 1 device and it works. So that's the one idiosyncrasy. A solution to that is you can actually hook up 3 at one time, and you can specify 37, 38, 39, and now you will capture every single thing that is advertising, and you're sure then that you'll pick up the connect that occurs. So that's one of the idiosyncrasies you have to deal with, is it's only going to listen on 1 at a time, and then it will follow whatever connects on that. So you have to sometimes specify listen on 38, 37, 39. So anyway, but I've already logged the file, like I said. So this PCAP NG file here is different than these other log files, right? This is that specific data that I'm getting from the Ubertooth. So let's drop that in here. All right. Let me make sure this is, okay, it is. So when you set this up, and you'll see this in the wiki over here, there are a couple of things that you need to do to configure this right here. You actually have to configure Wireshark so that it knows what protocol to apply to the data that you're getting from this pipe, because it doesn't have any way to recognize on its own that this is Bluetooth Low Energy data. So you have to set this up here so that it does know that it's BLE protocol to do the decomposition of this with. So once you've got that in here, then as you go through the data, you'll start to see the exact same stuff emerge, right? I'm looking down in here at this Bluetooth protocol, and I see these initial handles that are the service declarations that happen when they connect, and you'll see we're starting to get that data, and then here we go. We have the right commands, the same handles. And all of this was picked up by just entirely side sniffing that conversation, which is pretty scary. The encryption on BLE is pretty much broken. What little there is is an application you can get called Crackle, LE, right, the low energy, and use an Ubertooth, and it can basically pick up all of the handshaking that happens in the initial connection and just peel away all of any security that exists on BLE. So it's, I don't know, maybe that's why you have to turn Bluetooth on when you first boot up the Edison. All right, so that's kind of it. That's all of the details. Does anybody have any questions on any of that? There's a lot of content in here that I went through, a lot of stuff I threw at you all at once. Do you want to see it again? Yes?
How long did you spend figuring all this out?
So I have a degree in electrical engineering and a degree in computer science. So by way of background, I'm totally comfortable with the bits. So it only took me probably about a month of just dabbling in the evenings and weekends to get it all working. I feel as if, though, the learning curve for me was all about Bluetooth, and I just felt very comfortable with all the other packet conversation stuff. So that's, should be doable for everybody else, but I'm just saying that might make it a little less daunting. Anybody else? Yeah.
So after making it work, did you consider assigning unique colors to each individual on your team?
No, because I want to have a safe environment where people feel comfortable and aren't worried about being blamed for all of the things, really, right? The who broke the build is a joke kind of thing. And once you have that camaraderie enough where people feel comfortable with it, then sure, maybe do that. But just getting the habit of, hey, we have the bulb. There's enough of that internal hesitation of, I need to make sure I've run this locally and done my own build script, but so I know that I don't make that bulb red, right? So, but no, that's a pretty fun idea. I kind of like that. I might do that with a couple of the teams. Anybody else? I can see a few faces on the sides. There we go. Anybody else? All right, you want me to run it again? I had to unplug it a minute ago, and I just plugged it back in, so give me a second. Let's make sure this is up first. RF unkill, or RF kill and block. Got to do that too. I always forget that one. The one in the office, I actually set that into the startup script, so it just does it when it boots. And we've got, or I guess we had 6 bulbs all running off of one, and everything was working fine. I mean, Bluetooth in theory can handle 35,000 simultaneous connections without a problem. So there's that. All right, connected. Turn the bulb back on. Maybe. Okay, there we go. Okay, we're good there. Assign. And then we'll run this. Oh, I love it. It's so much fun. You want me to stop it and see what happens? See if we get it there in time. There we go. Yellow, that's what we got. So it is additive color codes then, right? Red and blue made yellow. Or red and green made yellow. All right. Well, I hope that you've enjoyed it. If you have any questions, feel free to come up and talk to me. GitHub, Jesse Phelps Build Light. I have the code up there. And thank you for coming.